What type of function is the first one? So I know what I have to do. What type of function is it? Perfect. It's a rational function. What can go wrong here? Right? What can go wrong is the denominator can be 0, and we have to exclude that. Good. So I have to make it a note that x minus 7 cannot be 0. Therefore, correct. So what is the domain then, since x cannot be 7? Very good. Awesome. That's it. This is the domain of this function. Very good. For those of you who came in a few minutes after we started, we're trying to review a little bit of what we just did from chapter 2 before we start chapter 3. Okay, in number 83, we're given two functions. We're asked to find only the sum, the product, and the ratio, and their domain. And we're asked to find the function composition without finding the domain for that one. I recommend start with a common domain first. That is the best thing to do. Find a common domain. So what is the domain of function f? Depending on what type of function is it. What type of function is function f? Yes, it's under the big umbrella of called what? What is that big umbrella that quadratic function corresponds to? A big name, very important name. The linear is there, the quadratic is there, cubic is there, fourth degree is there. What are those? Polynomials. They're all polynomials. So the big umbrella is polynomials. And we have in there linear, quadratic, cubic, fourth degree. All these, we said, all these have what domain? Of course. I can plug in x, I can replace x by anything I can dream of with no restrictions whatsoever. So the domain of f and g, all real numbers. What is the common domain then? Exactly. Very good. The common domain is all real numbers. Now we're ready to create the sum. The sum, I didn't select the difference, so just the sum, product, and the ratio. So f plus g of x, I have to write the definition first. What is the definition of f plus g? F of x plus g of x. This is a sum. When we say f plus g, we mean the sum. I copy f, which is x squared plus x plus 1. I copy x squared minus 1. I see these two go away. I combine like terms, 2x squared plus x. So the sum of these two functions is a new function. That is 2x squared plus x. Any questions? Yes, please.
This lecture is going to be up on your campus, right?
Everything I say or write is going to be up. Yes. Unless there is a glitch. But if anything goes smoothly, I will always have everything posted. Okay, fg of x, by definition, this means f of x times g of x. And what is the next step? I replace f of x, and this is x squared plus x plus 1. I replace x squared minus 1, and I distribute using the distributive law. I prefer distributing from the small one, but it doesn't matter. You'll still get 6 terms no matter what. So x to the fourth plus x cubed plus x squared, distributing x squared to these three terms. Now I'm distributing -1, negative x squared minus x minus 1. Only these two go away. And in descending order, I have x to the fourth plus x cubed minus x minus 1. Are we comfortable with all this so far? Is this clear? Yes, everyone? Okay. Then we are asked to find f over g. I have to write the definition. What does this mean? Perfect. Exactly. Common sense. So the numerator is x squared plus x plus 1, and the denominator x squared minus 1. Remember, the common domain is the domain of three functions only: f plus g, f minus g, and fg. The common domain may or may not be the domain of the ratio. We don't know till we create the ratio. So now let's look at the ratio, which is f over g. And what will you say? What will you do immediately? Careful. This is a quadratic expression. I have to get two solutions. Right. Because you can write this. Always remember, if the polynomial has degree 2, 2 solutions. If the polynomial has degree 3, 3 solutions. So therefore, the domain of the ratio is not the common domain. From the common domain, we must exclude what? Very good. So we will write negative infinity to -1, union -1 to 1, union 1 to infinity. In plain English, exactly what you just said. Everything but -1 and 1. We're also asked to find the function composition.
What's the symbol?
F comp G. F comp G. What is the definition of this? Yes, this is f of g of x, and I have to start with the inner function. So this is f of x squared minus 1. Now I have to look at f. What does f say? It says whatever squared plus whatever plus 1. So can anyone dictate what we should write? Whatever squared plus whatever plus 1.
X squared plus x plus
Whatever squared plus whatever plus 1. So the whatever now is x squared minus 1. So that's why I read the pattern back to you. Whatever squared plus whatever plus 1. But this is the whatever now. So this is whatever squared plus whatever plus 1. Is that okay, everyone? Okay, so now I still have to expand and simplify as much as I can. So when I square a binomial, how many terms do I have to write? Please think, and do not say 2, please. 3. Very good. Thank you. The first term squared.
4.
Very good. Minus 2.
2x
Very good.
plus 1.
Awesome. So then x squared minus 1 plus 1, these two go away. So we have x to the fourth minus x squared plus 1. This is the function composition. I will not ask you to find the domain of the function composition because I think it's beyond the scope of this course. Okay, so we completed 77 and 83. Now we're moving on to 89. So in 89, we are given h of x, which is x squared plus 2x minus 1 raised to the fourth power. And they want us to find an inner function and an outer. There's more than one correct answer. But let's think for a moment and come up with an inner and come up with an outer. The idea is always in the order of operations here. what I apply first and what I apply second. What will be the inner? The function that I will evaluate first. If I want to evaluate age, let's say at 5, which function will I evaluate first? It's the inner, which is? Exactly. Very good. Exactly what's inside the parentheses. Once I plug in 5, this becomes a number. A simple, plain number. Now, which function I apply to this number? Yes, x to the 4th. So the inner is x squared plus 2x minus 1, and the outer is x to the 4th. We are given f of x, which is 4x minus 4. They're asking us to find f inverse, and they're asking us to graph both on the same coordinate system. Okay, first of all, I have to ask myself, because the problem may ask me, is this function one-to-one? Because we know that only one-to-one functions, what? Have an inverse function. So I'm asked all of a sudden to find the inverse function. I'm given a function, and I'm asked to find the inverse. I have to think, well, is this function one-to-one? What type of function is it? And if you say polynomial, I have to agree. But specifically, exactly, linear. Is the linear function one-to-one? Yes, by the horizontal line test is one-to-one. So for each y value, there is only one x value. Awesome. So then I know it's one-to-one. I can find its inverse. Step 1. There is a 4-step procedure for that. Step 1. Yes? Yes, I replace f of x with y because it's the same thing. F of x and y are the same thing. Good. And step 2. Right. Why would I be allowed to interchange? Why all of a sudden I make x y and y x? Exactly. Because the y value of the function becomes the x value for the inverse. That's why I'm allowed to do this. Very good. Step 3. Solve for y. I'm adding 4 and dividing by 4. So then y equals x plus 4 divided by 4. And the final step, now this is exactly what I want. So what do I want? To replace this by f inverse of x is x plus 4 divided by 4. Good. Since it's a linear function, it wouldn't take long to find which specific points, which are very important. The x and y intercepts. Very good. So let's start with x equals 0. If x is 0, how much is y? Perfect. Which ordered pair did we just determine?
X, y.
0, negative 4. 0 for x, negative 4 for y. The other one is when y is 0. Remember, you have to imagine that you're moving negative 4 to the other side, unless you want to write it, which is fine. 4 on the other side, so 4 equals 4x. How much is x? Exactly. What is the ordered pair now? Perfect. So let's graph. We plot these 2 points, and we graph the line. Zero, negative 4, and 1, comma 0. I connect and extend the line. Please write somewhere what it is. So this is f of x equals 4x minus 4. Anywhere you want. Up, down, left, right. So we don't forget what this is. Now I will graph. And please tell me what am I graphing now? In transformations, this was the first function we looked at. The simplest possible linear function. What is it? That's it. The simplest possible function, period. Okay, so now without any calculations, I would like you to give me two ordered pairs so that I can graph the inverse. Two ordered pairs, please.
Zero and 4.
No. Exactly. We have to reverse. If this was 0, -4, then we have -4, 0. Right? These two have to be symmetric. So if we had 1, 0, what is the point for the inverse? Very good. And also don't forget, if a function crosses y equals x in a point, the inverse must cross at the same point. Why? Because here the point is x, x, basically. It's the same x, the same y. So that point doesn't go anywhere. So this is f inverse of x, which is x plus 4 divided by 4. As you notice, the graphs of f and f inverse must be symmetric with respect to this line. I don't have a perfect graph, as you notice. They're not completely overlapping, but they should. My graph is not perfect. So these two should be at the same spot. These two should be at the same spot, but if you can look through, it's not perfect. But that's what has to happen for f and f inverse for any function and its inverse. Okay, perfect. Moving on. Last two. We are given two ordered pairs to find the distance and the midpoint, and then talk about this. And then we can start chapter 8. I just wanted to give you a refresher, quick refresher of what we studied from the moment we finished test 1. So we are given two ordered pairs, and 2, 6, and -12, 4. We want to find two things. We want to find the midpoint, and we want to find the distance. The midpoint should be just a breeze. We are adding the x values. What do we get when we add the x values? -10, and we have to divide by 2. And the answer is, we have to add the y values now, and we get, yes, and we divide by 2, and we get 5. This is the midpoint, and it's done. Now for the distance, please remember the formula. It's very important because it's also connected to the equation of the circle. The formula is x2 minus x1, everything squared, plus y2 minus y1, everything squared. Please label them so we don't make a mistake. I label the first point x1, y1, the second one x2, y2. The order is not important. You dictate which order you prefer. But we have to keep them in the order x1, y1. So now, I like to write them underneath so I don't have to write the whole thing again. So this is my x2, and this is my x1. This is what my y2, and this is my y1. So then the distance will be the square root of, remember, we can never find the negative number underneath. This is a number that is squared, so it must be positive. This is a number that is squared, it must be positive, and we are adding two positive numbers, correct? Okay, so -12 minus 2. -14 squared, so I can write it as 14 squared, is the same thing, plus 4 minus 6. And -2 squared is 4. So 14 squared is 196, plus 4 is 200. I will have to simplify it into 102. So I will write that the distance is the square root of 100, which is 10, and the square root of 2, which is the square root of 2. Any questions so far? Any questions? Last problem here. We are given this equation, and we're asked, does it represent the equation of a circle? I have no idea. So let's copy it. So this is x squared plus y squared minus 4x plus 2y minus 4 equals 0. So if I manage to put it in this form, x minus h and y minus k, if I manage to change all this into something like this, then I would say yes, it's a circle, as long as this is not 0 or a negative number. So what does this say? It says this is a completed square with x. These are numbers. What does this mean? It's a completed square with y alone. I don't see x and y in the same square. So a completed square with x, completed square with y, plus between the two of them and a number on the right-hand side. Hopefully it's positive. Okay, so then I'm looking at x squared and negative 4x, and I know what I have to add to both sides. What do I have to add to both sides to complete this square? 4, right? Because it's negative 4 divided by 2, which is negative 2. We square negative 2, and we get 4. I would like to remind you that this was the method we applied in solving quadratic equations, and I said, no, this is not for this. It's for this. Okay, so then the left-hand side, these 3 are here. What is in here that we square to get 1, 2, 3 terms? Of course. Of course. Exactly. What we squared to get 4. Absolutely. Thank you. Very good. Now we have to complete the square for y squared, for y. What do we need to add to both sides to complete the square with y squared and 2y? And we have to add both to both sides. So the middle coefficient is 2. We must divide it by 2. Right, the last term can never be negative. So when I expand this, the last term will never be negative. Yes, indeed. So 2 divided by 2 is 1. 1 squared is 1. Very good. So now 1, 2, 3 are here. What's in there that will give us, when we square it, y squared plus 2y plus 1? Perfect. Exactly. What we squared to get the 1. So now, what is left on the other side? So let's see what we have not used yet. We have not used this. We have not used this. And we have not used this. But this one has to come from the other side. So what is left on the right? Exactly. 4 plus 1 is 5, and I bring a 4. So 4 plus 4 plus 1. Now I'm asking myself, is this a circle? What is its radius? Perfect. What is its center? Remember, there is a minus in here. So the center is, the x-coordinate is and the y-coordinate is -1. Good. This was a quick review, not as quick as I was hoping it would take, but that's fine. Chapter 3. Please do not fall behind with my math lab work. You have all the information to finish Chapter 2 homework. Okay, in Chapter 3, we're going to talk about polynomial and rational functions, finally. And you can say, again, we already talked about polynomials. We grabbed so many, true. But now we're going to talk more detail. So polynomial and rational functions. So polynomial, we are not going to talk about linear, right? We exhausted everything about linear. But we will start with quadratic. Although we use quadratic functions in transformations, we're going to go into more detail, and we're going to look at word problems that use quadratic models in real life situations. We are going to look at a third degree polynomial function, also the fifth, and so on and so forth, any odd degree. And of course, we are going to look at the fourth degree and the sixth and any even. So this is odd, not odd symmetry, right? Not symmetric with respect to the origin. Odd degree and even degree. Now, I will repeat this several times. There is some similarity between any odd degree and the linear. And I will show you what the similarities are. There is some similarity, not everything, but something that is very important, that all even degree have as well as quadratic. Okay? So once we understand how to graph pretty much linear and the cubic, we will know to graph any other odd degree. Once we understand how to graph quadratic and what is the model, what is the pattern, then, and we understand the fourth degree, we will have absolutely no secret for any even degree. So once we understand these two, all odd degree functions will be a breeze. Once we understand these two, all even degree functions will be a breeze. Okay, polynomial functions, of course. Okay. So let's start with quadratic. And quadratic is all section 3.1. So I'm going to go directly to graphing, explain the two models, I should say two representations of the quadratic function. We're going to graph and then look at word problems. So 3.1, quadratic functions. So the quadratic function, as we know, can be given to us in two different ways. It's pretty much the same thing, but it looks differently. And you will tell me the difference between the two. So this is the general form, which we know from the quadratic equation, from the quadratic formula as well. No secret here. The next one is also no secret because of transformations. Here it is. H and K are not coming from the center of the circle. But we happen that we use the same notation. So what will be this, you think, H comma K? Well, let me give you an example, because we had something like this in transformations. So here an example on the side. Let's say we have f of x equals 2, x minus 1 squared plus 4. I no longer need to graph this function. I have it in my head already, right? It's x squared. Where does it go first? To the right or right one. Very good. Then vertical stretching. And then up 4. What is its vertex? Careful. We said to the right one. right? We said to the right one. So what is the vertex? 1, 4. What do you think is this? H comma K? The vertex. Exactly. See, we didn't even graph the function. I just looked silly with my arms up, and we determined the vertex without even graphing it. So that is what H comma K represent. Okay, so this is the general form. Although the book says that this is the general form, it doesn't matter. I'm not going to ask you the name. Obviously, I consider this the vertex form because I can look at it and read the vertex. But they consider that this is the general form and this is I don't know what. Okay, it doesn't matter. So the function can be given in 2 different ways. Let's say we're given a function like this first to graph. Then we're given one like this to graph exactly this time, not using transformations. And then we look at word problems. Okay, let's say 32 on page 360. And we are given f of x equals 5 minus 4x minus x squared. So the difference, one more time, the difference between these two is basically just the way they look, not the graph. This has the completed square and this one doesn't. So if I perform the completed square on this one, I'll get this. So they're not different. This one allows us to read the vertex right away. This one needs work to find the vertex. But this one is given to us. This form gives us the vertex. Okay, so first I will ask myself, I'm asked to graph, of course. Graph this function. Exactly, right. Okay. So the first thing I say to myself, okay, or ask myself, what is it? Well, it's a quadratic function. Secondly, I realize it's not in descending order. I will rearrange it. And then I will start answering, and I will list this for you. Okay, number 1, I will ask you to find the shape. Because we already know from transformations that the quadratic function looks either like this or like this. In this situation, this is the vertex. In this situation, this is the vertex. But here it's a minimum, and here it's a maximum. So how do I know the shape if it's this or this? By simply looking at the function. The leading coefficient tells us. The leading coefficient, if it's positive, the function has a minimum. If a is negative, the function is a maximum. So a equals -1, max. When a is positive, min. So this is not our case. This is our case. Because the leading coefficient is negative. In step 2, I will have to find the vertex. There is a formula for the vertex. So let me go back to something we studied before, so maybe it's easier for you to remember. Do you remember when we used the quadratic formula on solving quadratic equations? So what was the top? I don't care. Over 2a. This is all I have to remember. The vertex has the x coordinate -b over 2a. If I remember the quadratic formula, I will always remember the x coordinate of the vertex. Now the question is, what is the y coordinate of the vertex, and how do I determine it? How do I determine the y coordinate? I'm giving you a function, and I'm telling you x is 5, find y. What will you do? So let's say this is 5. We haven't calculated it yet. I'm just making a number up. So I'm giving you the function, and I'm telling you that x is 5. How will you find the y coordinate? Of course, that's all I need you to say. Plug it in. It doesn't come from anywhere, but f of that value, correct? Good, so let's write f of negative b over 2a. F of negative b over 2a. Now we're ready to find negative b over 2a. That's why I needed it. That's the second reason why I needed this in descending order. Mandatory. So negative is outside from the formula. How much is b? Negative 4. 2 times a. 2 times a. Negative 2. There are 3 negatives in here. The answer is? There are 3 negatives. Negative 2. So the vertex has the x-coordinate negative 2. Now I have to plug in the function what again? To get this value. Correct. Very good. So this is indeed f of negative 2. I'm just trying to make sure that everyone understands that. So f of negative 2 will be, careful how you plug it in. The negative sign has nothing to do with what you square. Parentheses, negative 2 squared, minus 4, parentheses, negative 2, plus 5. By the order of operations, I have to square first. So negative 2 squared is? With minus in front? Perfect. Negative 4 times negative 2? Perfect. And plus 5. So 5 minus 4 is 1. 1 plus 8 is 9. So the coordinates of the vertex are negative 2, comma 9. Is that okay? Any questions? Okay. Number 3. X-intercepts. And I want to write here, comma, if they exist. And I want to talk about this before we continue. What does this mean? So one more time, which shape does this function have? A maximum or a minimum for our case? Maximum. There are 3 possibilities for maximum. So this is an explanation of this. So there are 3 possibilities for a maximum. A function, a quadratic function with a maximum, can do this. How many times does it cross the x-axis? Perfect. It can do this. How many times does it cross or touch the x-axis? Once. Or it can do this. How many times does it cross the x-axis, or how many x-intercepts does it have? None. So remember, when we solve a quadratic equation, we always have to get 2 solutions. These are 2 distinct solutions. These are 2 solutions, but they are the same. These are 2 solutions, but they are not real. They are imaginary numbers, like the square root of negative 4. Okay? So let's also connect this to the quadratic formula. Now, if you remember, the quadratic formula, and I know you remember, is this. This quantity, not the square root, just this quantity inside, is called discriminant. Sorry, I ran out of room. Discriminant. Can you tell me what type of number will the discriminant be if the quadratic equation crosses the x-axis twice? In other words, it has 2 x-intercepts. What type of number should this be? Numbers can be positive, 0, or negative. Positive, because there are 2 distinct solutions. For example, like this is 4. Whatever plus or minus 2 over this. So that's how we get those 2 distinct solutions. So we say b squared minus 4ac definitely strictly greater than 0. Okay, now if there is one solution, what can you say about the discriminant? Exactly. Although there are two solutions, but they're identical. Perfect. And what is the last option? Exactly. So when the discriminant is negative, b squared minus 4ac is less than 0, there are no real solutions. There are two solutions, but they're not real. Two solutions, but they are the same. Two distinct solutions. Okay, so now when we find the x-intercept or x-intercepts, what do we have to set? Anytime we find the x-intercepts, we set, what is the equation of this line? It's a horizontal line. It's not position, it's altitude. It's altitude. Exactly. So for the x-intercept, I have to set y equal to 0. But I don't want to waste my time. Of course, I have to write negative x squared minus 4x plus 5 equals 0. But I want to analyze and see what happens here. Look at the vertex, negative 2, 9. Let's identify which situation we're in. Because if it's this, I'll say they don't exist and move on. Is it this, this, or this? Let me write it one more time. Negative 2, 9. This will tell us exactly which case it is. Exactly. Because the ordered pair is somewhere negative 2, 9. It's not negative 2, 0. And it's not negative 2, negative 3. So the two solutions exist. And they are distinct. It's case 1. The discriminant must be a positive number. Good. So now I'm asked to solve this equation. It's quadratic. I have to get two solutions. And you already know what we should do first. Absolutely. Correct. Very good. Always simplify the equation. Always refuse to solve a quadratic equation with a negative leading coefficient. So this is x squared plus 4x minus 5 equals 0. I will never complete the square. I cannot take square roots, so I'm down to two options. Which options? Factoring, or let's see if we can factor it. If we can factor it in 10 seconds, move on to the quadratic formula. But can we factor it in 10 seconds? Very good. So it has two x-intercepts as expected. One has x equals perfect, and the other one, that's it. But we have to be careful, which ordered pairs did we just determine? And if you say negative, I'm not saying you would, but if you say negative 5, 1, that's a big problem. That's why I need to identify them right now. Perfect. Correct, because we said y equal to 0 to determine these values of x. Awesome. Now, mind you that all this takes a long time because it's the first problem. That's why I'm going slowly over each and every step. But normally it should take about 3 minutes, the whole thing. Number 4. What do you think number 4 will be? So number 1 was the shape. Number 2 was the vertex. Number 3 was x-intercepts. What do you think I'm going to determine now? Of course. The y-intercept will always exist. There is no comma if it exists. How do I determine the y-intercept for any function? Perfect. So let's find f of 0, go back to the function, and what do we get? Very good. So the ordered pair is? Very good. Five and 6 are just words. I did not mention before, But it's clear that quadratic functions are symmetric. The graphs are symmetric. I'm not talking about odd or even. I'm talking the fact that they are symmetric with respect to their own axis of symmetry. So this can be the case. Well, I'm not talking about odd or even, but I'm saying this side of the graph is symmetric of this side of the graph with respect to this line. So we'll have to write that the x equals is the axis of symmetry. In our case, let me remind you, the vertex was -2, 9. Which vertical line passes through the vertex that will definitely be the axis of symmetry of this parabola? Very good. X equals -2 is the axis of symmetry, will be the line, the vertical line passing through -2, 9. Last question here is, does this function have a max or a min? Max. Max value of f of x is exactly. And I want to add number 7, which is the range. We haven't even graphed the function, but we know the range because we understand how this function looks like. Has a maximum, has a vertical of the axis of symmetry at -2. It has a maximum value of 9. What could be its range? Exactly. To 9. Very good. And we haven't even graphed it. That says a lot. We learned a lot about this function. Okay, so when we graph it, we always start with the vertex. So the vertex was -2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here. The next step is the axis of symmetry, which is not part of the graph, will not be graphed as a solid line. It's only supposed to help us keep the graph in shape. Nothing else. It has no other meaning. So x equals -2. Now I know it crosses the y-axis at 5, 2, 4, 5. I know the x-intercepts are -5, 3, 4, 5. -5 and +1. I'm going to try to graph it as smoothly as possible, as continuous as possible. My graph is not perfect, but not too acute at the vertex. And then I have to write -x² minus 4x plus 5. And this graph was done step by step, not using transformations, and all the minute details are presented. Okay, let's look at one with the other, where the vertex is determined. It's very straightforward. And then let's look at a word problem. Let's look at 12 on the same page. F of x equals -2 in parentheses x plus 4 squared minus 8. The question is not asking us to graph using transformations. The question is asking us to graph accurately. We have to go through 7 steps. In step 1, notice one thing. All the time in the past, when we graph the function, what did I ask you to determine first? Always. First step, ever. Right. This is a polynomial function, that's why I didn't say it. But I should have said it from the very beginning. We understand that the domain is all real numbers. Okay. Good. So, shape. This is the A, -2. So it's a maximum or a minimum? Yes, again a max. Number 2, the vertex. Now the vertex does not need any calculations. If you forget what the vertex is, just use transformations and you will identify the vertex in a blink. Careful. -4, -8. Because x plus 4 is a transformation that moves x squared to the left 4, And -8 has to stay. It has to be down -8. There is no change there. Perfect. Okay. Now, in number 3, X-intercepts, if they exist. Let's picture the graph, because we don't want to waste our time. If they don't exist, we move on. So what do you think? Do they exist? They don't exist. Why? Because the maximum value is under the x-axis. I know it's a maximum because that's the shape, and the maximum y value is -8, which means I would be wasting my time applying the quadratic formula or who knows what, or using the taking square roots or what, so on and so forth. None. Number 4, this will always exist, the y-intercept. I have to find f of 0. Let's find f of 0 together. How much is 0 plus 4? How much is 4 squared? 16 times -2. -32 with -8. -40. Good. 5, 6, and 7, just words. See, the first problem took us 10 minutes. Now this one takes us 2 minutes. So 5, the axis of symmetry of this parabola. They're called parabolas. The graph of a quadratic function is called a parabola. So 5. So x equals -4, axis of symmetry. What is the maximum value? And what about the range? And we haven't even graphed it. But we know everything about this function now. Very good. So let's graph. Since the vertex is so low, I will plan ahead and do this. And -40, I'm going to say -10, -20, -30, -40. This is the y-intercept. -8, -4, comma -8, 2, 4. I'm going to say here, I'm going to draw the axis of symmetry, which is x equals -4. And I'm going to try to make it as symmetric as possible. I will find another point symmetric on the other side, equal distance, because it's a symmetric graph. And here's the graph. Please write f of x equals -2, x plus 4 squared minus 8. And now finally we're ready to look at some more problems. Why was this so important to go through all these steps? It's because